Hey everyone, and welcome to our deep dive, into the world of AI. It's artificial intelligence. It's kind of crazy. We've got like a whole bunch of different sources here. We've got textbook, like the classic AI textbook. We've got some recent research papers and even like these historical reflections on AI. It's pretty wild.
Yeah, and it's interesting how AI is often seen as, this futuristic thing. But looking at what you've given me, it seems like it's already a part of our lives, like in ways we don't even realize.
Okay, so where do we even begin with all of this? Well, the textbook, Artificial Intelligence, a Modern Approach, it starts off, it tries to define AI as designing intelligent agents,
Yeah.
like systems that can perceive their environment and then take actions to like achieve goals.
And it's a bit of a mouthful, isn't it?
It is. It is.
Yeah, it is a bit dry. I think your historical reflections actually help to explain like why that is.
Hmm.
The earlier AI folks were really focused on copying how humans think,
Yeah.
using logic and symbols to solve problems, almost like a mathematician, proving theorems.
And AI has come a long way since then, hasn't it?
Oh, yeah, absolutely. It's so much more than that now.
Right. One of the research papers you gave me, actually, it talks about how AI is now being used to analyze like patterns in classical music to help composers understand, the emotional impact of different melodies, which I think is just mind-blowing.
It's amazing, right? It's not just about mimicking us anymore. It's about AI helping us to be more creative, like pushing the boundaries of what we thought was possible.
So this deep dive is really about understanding not just what AI is, but also how it's changing everything around us, like
Oh,
this hidden force shaping our world.
absolutely. And to understand this force, we need to understand the different ways you can create these intelligent agents. The textbook talks about a few approaches, but the one that's really taking over is machine learning.
Okay, so machine learning, that's where the algorithms learn from data, right? It's
Mhm.
kind of like training a dog, but instead of giving it treats, you're feeding it data.
Yeah, that's actually a pretty good analogy. But instead of learning tricks, they're learning patterns. And those patterns allow them to make predictions or decisions. And the key here is the huge amount of data. One of your research papers compares this data to a vast ocean. Like each data point is a single drop of water.
So the more data we give these algorithms, the smarter they get. Is that what we're saying?
Well, in a way, yes. But it's not just about how much data there is, it's also about the quality of the data. Imagine you're teaching an AI to recognize different types of flowers, right? If you only show it roses, it's going to have a hard time telling a sunflower apart from a rose. The data needs to be diverse, like it has to show the full picture.
That makes sense. But talking about all this data makes AI sound kind of impersonal, like it's just a big number crunching machine. Where does the intelligence part come in?
That's where it gets really interesting. One of the research papers you shared talks about deep learning, a kind of machine learning that uses something called artificial neural networks. And they're inspired by how the human brain works.
Neural networks. So are we like building artificial brains now?
Yeah. It's not that straightforward, but the idea is similar. These networks have layers of interconnected nodes, and each layer, it processes information and passes it on to the next one, like a chain of thought.
So are we talking about creating machines that are conscious,
Uh-huh.
like that can think and feel the way we do?
Well, that's something that philosophers and scientists have been debating for a long time, and we'll definitely get into those questions later. But for now, let's stick to what deep learning can actually do.
Okay, so like what are some examples? How is this deep learning stuff being used in the real world?
Well, one of the coolest examples from your sources is in medicine. Researchers are using deep learning to analyze medical images, things like X-rays and CT scans, and they're doing it with an accuracy that's almost as good as human experts.
Wow. So AI isn't just playing chess anymore. It's actually helping to save lives.
Exactly.
Hmm.
And that's just one example. Deep learning is being used in self-driving cars. It's in the personalized recommendations you see online. Even in creating art and music, it's like this incredibly versatile tool with endless possibilities.
Okay, so we know AI is powerful and it can do all these amazing things, but I'm still not quite clear on how we teach these AI systems, these intelligent agents. How do we make sure they're learning the right stuff?
That's where the idea of learning and machine learning really comes in. The textbook, it really emphasizes that data is key, especially for deep learning.
Right. So it's all about feeding the algorithms tons of data, but how does that actually translate into like learning?
Think of it like teaching a kid to ride a bike. You wouldn't just hand them a physics textbook and expect them to figure it out, right?
No way.
You'd show them, how to pedal and let them practice, make adjustments along the way.
So it's like showing the AI a bunch of examples and letting it kind of learn by trial and error.
Exactly. That's actually called supervised learning. You give the AI what's called labeled data, so each example is tagged with the correct answer. It's like giving the AI training wheels.
Okay, I get it. But what about when we don't have all the answers? Like, what if we want the AI to figure out patterns on its own without us telling it what to look for?
That's where unsupervised learning comes in. It's like taking the training wheels off. You let the AI loose on this data that's not labeled, and it has to find the patterns or structures all by itself.
That sounds a little chaotic.
Hmm.
How do we know the AI is actually learning something useful?
Well, it is a bit more open-ended, and that's why it's often used for more exploratory tasks, like grouping similar data points together. It's called clustering or simplifying data by finding the most important features.
Okay, that makes sense.
Hmm.
So we've got supervised learning with training wheels and unsupervised learning without. Is there like a third type of learning?
There is. It's called reinforcement learning, and it's kind of like training a pet.
Oh, okay.
So the AI interacts with an environment. It takes actions and it gets rewards or penalties based on what it does. It's all about trial and error. The AI figures out which actions get the best results.
Like giving a dog a treat when it sits or scolding it when it chews your slippers.
Exactly. Over time, the AI learns to maximize its rewards by figuring out the best moves. This approach has been really successful. In teaching AI to play games, control robots, even things like optimizing traffic flow in cities.
It sounds like there's a whole toolkit of learning methods for AI.
Yeah.
But whatever method you use, we need a way to check how well these AI systems are actually doing. We don't want to just trust them blindly, right?
Right, you are evaluating AI is crucial. It's like making sure they're doing their job properly. And the textbook goes into detail about the different ways to measure their performance. It depends on the task, of course.
So it's not just about whether the AI gets the answer right or wrong. It's about making sure it's getting there in a way that makes sense.
Exactly. We need to look deeper. Assess things like accuracy, precision recall, even fairness. Like if we're using AI for loan approvals, we want to make sure it's not discriminating against certain groups of people.
Makes sense. So we've covered how AI systems learn and how we can check if they're doing a good job. But there's one big question that's been bugging me since we started this deep dive.
What's that?
This whole idea of superintelligence. The textbook mentions, Alan Turing's prediction that machines would eventually become smarter than humans. Is that really a possibility, or is it just science fiction?
Oh, that's a question that sparked a lot of debate. And I think it's one of the reasons we're so fascinated with AI. The truth is, there's no easy answer. Some experts think superintelligence is inevitable. Others say it's just hypothetical. Unlikely to happen.
So we're basically in uncharted territory.
Yeah, kind of. But the fact that we're even thinking about it, it says a lot about how far AI has come and the potential it has. Imagine a world where AI could solve problems that have been plaguing us for centuries. Things like climate change, disease, poverty. It's both exhilarating and a little scary.
Definitely both.
Hmm.
It's like we're on the edge of something brand new, with incredible opportunities but also unknown risks. Where do we even begin to navigate something like that?
Well, the textbook offers some steps, and thankfully they line up with a lot of the stuff in your other sources. First and foremost, we need more research into AI safety. It's like exploring a new jungle. We need to map the terrain, figure out the dangers, and come up with ways to stay safe.
So it's not just about building AI that's smarter, it's about building AI that's safe.
Exactly. We need to be proactive, not reactive. And that means getting everyone involved. AI researchers, ethicists, policymakers, even the public AI shouldn't be developed in a vacuum. We need everyone working together to make sure it's developed and used responsibly.
That makes sense. It's like we need a global conversation about AI so
Right.
we all understand its potential and its limits and can steer it in the right direction.
I couldn't agree more. And that's why deep dives like this are so important. They're a chance to explore, to think critically, and to have those informed conversations about this technology that's changing everything.
I know I feel a lot more informed than when we started, but I also have to admit, it's a lot to take in. It's like this deep dive has opened up a whole new way of thinking, a whole new set of questions about the future of humanity and our relationship with technology.
That's a perfectly natural reaction. AI makes us question our assumptions, our limits, and it makes us imagine new possibilities. But it also reminds us that we're the ones in control. The choices we make today will shape the future of AI and how it affects our world.
So what's next on this deep dive? We've looked at the theory, the learning methods, the philosophical stuff. Where do we go from here?
Okay, so we've spent the last couple parts, really getting into the nitty-gritty of AI, like how it learns the philosophy behind it all. It's been a lot, but now I'm kind of ready to see AI in action, like how it's actually being used out there in the real world.
Well, you're in luck because the sources you gave me, they're full of real-world examples. It's like a showcase of all the amazing things AI can do. Awesome. Let's dive in. Let's start with something that's become like a part of everyday life. Natural language processing, NLP. The stuff that powers those voice assistants, the chatbots, even those translation tools that can translate languages in real time. It's
Yep.
pretty crazy how far that's come.
It really is. And one of the research papers you shared, it goes into the technical details behind how it all works. Specifically, these things called sequence-to-sequence models.
Okay, that sounds pretty complicated. What are those exactly?
Imagine trying to, transcribe a melody from a piano to a violin. You're not just copying the notes, right? You're capturing the feeling, the phrasing. Sequence-to-sequence models are kind of like that with language. They take a sequence of words, like a
And
sentence in French, and they output the same thing in English, but it's not just a word-for-word translation. They try to keep the style and context, too.
so it's like having this amazing translator that really understands the nuances of human language.
Exactly. And these models, they're trained on massive amounts of text data. So they learn the relationships between words and phrases in different languages. It's like they're constantly studying, getting better and better all the time.
That's impressive.
Mm-hmm.
But language isn't just about translating words. It's about understanding meaning, intention, emotion. Can AI really grasp all of that?
Well, it's a tough challenge, but the research suggests they're getting there. One paper talks about something called sentiment analysis, where AI can analyze text and figure out if the feeling behind it is positive, negative, or neutral.
So like if I'm being sarcastic online, the AI could actually pick up on that.
Yeah, exactly. It has big implications for things like, monitoring for hate speech online or even understanding customer feedback.
Wow, that's pretty amazing.
Mm-hmm.
And maybe a little scary too. But let's switch gears for a bit and talk about something that's often linked with AI games. The textbook actually mentions game playing as like a classic AI application, something that's been around since the early days.
Right. Games have always been this testing ground for AI. Those early systems like Deep Blue, the one that beat Garry Kasparov at chess, they showed how powerful AI could be in terms of strategy. But things have moved on a lot since then.
For sure. We've all heard about AI systems like AlphaGo that can beat even the best human players at really complex games like Go. What's behind those big leaps in game-playing AI?
A lot of it comes down to the combination of deep learning and reinforcement learning. Remember we talked about how AI can learn through trial and error, getting rewards for good moves and penalties for bad ones? That's reinforcement learning, and it's changed the game for AI, literally.
So these AI systems aren't just following rules someone programmed into them. They're actually learning and adapting as they play.
Exactly. And it's led to some incredible results. AI systems are coming up with strategies that even human experts hadn't thought of. It's like they're pushing the boundaries of what we thought was possible in these games.
That's mind-blowing. It
Yep.
makes you realize just how complex these AI systems are.
Uh-huh.
It's actually kind of humbling to know that we've created something that can outsmart us in areas we used to think were uniquely human.
It is humbling, but it's also exciting. It opens up all sorts of new possibilities, a future where human and artificial intelligence can work together and push each other to be better.
Speaking of working together, let's talk about robots. AI-powered robots have been a science fiction staple for years, but it feels like we're finally starting to see them become a reality.
Absolutely. Your sources, especially the textbook, they talk about how AI is transforming robotics. Robots can now perceive the world, make decisions, interact with their environment in ways we could only imagine before.
So we're not talking about those clunky old robots that can only do repetitive tasks. These are robots that can learn, adapt, even collaborate with us.
Exactly. They have all sorts of sensors that let them see, hear, even feel their surroundings. And they use complex algorithms to process all that data so they can navigate tricky environments, handle objects carefully, even respond to our commands.
It's pretty amazing stuff. But I guess there's some concerns too, right? What if these robots malfunction? What about the ethical implications?
Those are really important questions. As with any powerful technology, there are risks and ethical considerations we need to be careful about. The textbook stresses the importance of designing robots with safety measures, making sure they operate within certain limits, and that they're not biased in their decision-making.
So it's not just about building robots that are smart, but also robots that are safe and ethical.
Exactly. It's like raising a child. We don't just want them to be intelligent, we want them to be good people, too. The same goes for AI-powered robots. We need to make sure they're not just capable, but also trustworthy and aligned with our values.
This deep dive has been really eye-opening. We've covered so much, from the fundamentals of AI to its impact on language games, robotics. It's clear that AI isn't just something from the future. It's already shaping our world in big ways.
And it's only going to get more influential. What we've talked about today is just the beginning. As AI keeps developing, it's going to keep surprising us, challenging us, and making us rethink our place in the world.
It's a little scary, but also exciting. It feels like we're on the verge of a new era, where the lines between human and artificial intelligence are getting blurrier.
And as we move into this new era, we need to do it with both curiosity and caution. We need to be open to the amazing things AI can do, like solving some of our biggest problems. But we also need to be aware of the risks and make sure we're using it responsibly.
It's a tough balance,
Okay.
but it's one we have to find. So to everyone listening out there, as you continue to learn about AI, remember this. Stay curious, stay informed, and stay involved. The future of AI isn't set in stone. It's something we're all creating together.
Well said. It's been great joining you on this deep dive into the world of AI. I hope it's made you want to keep learning and exploring this incredible field.
And everyone listening, thank you for coming along on this journey with us. Until next time, keep questioning, keep learning, and keep pushing the boundaries of what's possible.